Hello friends. So this problem is about breaking of a block from ground. So problem says, figure shows a block A held at rest in a state when a spring of force constant K is in its natural length with an attached mass M at rest. So we have to find mass of block A, for which on releasing it, block of mass M will break off from the ground. So what are the things that is given? So we have been given mass of block and we have been given force constant, and we have to find mass of block A. Mass of block A. So this we have to find. So this is mass of block A. So let us say mass of block A is M. So let us assume this. So this is the mass of block A, M, and this we have to find. So try to visualize the situation what we have here. We have here a mass M and another block of mass capital M, and these two blocks are attached by a spring, and this spring is further attached by a thread which passes over a pulley, and this pulley is further attached by the ceiling. Now what will happen if you just leave this system? So this mass M, will start going in the downward direction. So after some time this block will go down and somewhere it will reach here. So after some time this block will reach here. And let us say this has gone down by a distance x. Now during this process what will happen? As this block is going down, this string will also stretch. So this string will also stretch by x. So x is also stretching in the spring. Now due to this stretching, what will happen? There is a force that will be applied to this block. How much will be the force? Force will be K times x. Now if this force is enough, then this block has a tendency to lift up. So at that point of time, to just break off, what we should have? We should have Kx is equals to mg. So you will write two equations. One equation is force equilibrium. So first equation you will write force equilibrium. And the second equation that you will write, that is energy conservation. Energy conservation. So let us pause this video and write these two equations and solve for M. So you have to solve for M. Okay, so let us solve this problem now. So first equation, since this is just lifting up this small mass M, then we can say force is equals to Kx is equals to mg. So this is force equilibrium. So the elongation in the spring that is required to just lift up this mass is mg by k. So this is required to just lift up or just break up this mass m. Now energy conservation. So what we will do is we will use loss in potential energy is equals to gain in the kinetic energy and plus gain in the kinetic energy. So you can say the loss in potential energy of block mass M is equals to gain in kinetic energy of a spring plus gain in potential energy of a spring and gain in kinetic energy of mass M. So let us write. So what is the loss in potential energy? So this mass has basically gone down by mgx. So this is the loss in potential energy. Where this all energy gone? Some part of this energy is gone in a spring. How much? Half kx square. And some part of this energy is gone in velocity of this mass, that is half mv square. So let us say velocity is v. But now this spring what will be this velocity? This velocity will be 0, because at this point of time a string cannot further elongate, because this has a 0 velocity. This is just a starting. This is just a starting the motion. And a string is basically inextensible. So if this velocity is 0, because this is just a starting, then this mass, that is this velocity, also has to be 0. This means this term is 0. So from here you can say mgx is equals to half kx square. This means mg is equals to kx by 2, and x is nothing but mg by k. So if you put this, so you will have mg is equals to kx by 2, and x is nothing but mg by k. So from here you can say this m is equals to m by 2. So if this mass, that is m, is half of this mass, then only this can break off this ground. So in this problem, only one important point is, at the time of lifting, this velocity will be 0. So velocity of both block will be 0. There are two reasons. Basically one reason, it can be said in two ways. Reason is the string cannot further elongate, or a spring cannot further stretch. This means this is the maximum stretch in the string to just lift off this block of mass, a small m. So I hope you enjoyed this video, and if you enjoy, please share with your friends. Thank you.